Hi, all right. So let's start looking at part four for the ViZDoom. So I'm going to assume that you've watched the parts one to three, and I'll put the links for one to three in the description of this video. I'm in a bit of a loud coffee shop, so even with the mic, you can probably hear background noise, but it's kind of more fun to sit here recording than to sit at home recording. So I hope you can handle it. All right, so since part three, I made a couple of changes. So like before, I was using some GitHub repository called pub prototyping, and now I've created one called YouTube demos. So if we go to here, so I've created this repository called YouTube demos. I've given it an MIT license, and there's a folder called ViZDoom with the script from the end of part one, the end of part two, the end of part three, and after this, we'll also have the end of part four. So we're going to start from the part three. I'm going to copy it to part four and then start modifying it. Well, I'll copy it to part four and then we can remember what it does. So let's copy it across to ViZDoom and then we'll copy that to part four, and then I'll save that up later. Apparently, I can't use the copy command. So let's take the part three, copy to part four, and then we're going to open that up. All right. So here we have the part four. Let's hide the minimap. All right. So we have created a neural network that's a convolutional network that has like a couple of layers, a couple of convolutional layers, a linear layer. It's got a forward, which is like putting the input, which is an image from the ViZDoom game, putting it through the convolutional network and getting the output, which is the choice of the action. So reminder, what we're doing is we are using ViZDoom, which is it's an adaptation of the original Doom game. I believe it's using the actual source code for Doom because Doom was made open source at some point. So Doom is an FPS, like really well done from like 94 or 93 or something like that. And then the idea is we're going to use Doom as a reinforcement learning environment. So we'll get the computer to, we'll put the computer into the Doom environment and we're not going to tell it what to do, and it's going to learn itself like what to do, how to win. And basically the reward it's going to get is like when it wins the game, it gets a positive reward, and when time passes and nothing happens, it gets a negative reward. And just from these rewards, it's going to have to learn somehow. And we are going to write the code to get it to learn. So what do we have so far? We have, this is like the draft model that's going to learn. So it's got a couple of convolutional layers, and the idea is that these are going to look at what you see on the screen when you're playing Doom. So you're going to see like the environment in front of you and any monsters and so on. And then the output of this is like the choice of the next action. So you're playing the game, you can move left, you can move right, you can shoot. Depends on the scenario. There are other actions possible, but in the simplest initial scenario, you can move left or right and shoot. And there's a monster ahead of you that sort of moves left and right, I believe. I don't know if it moves actually, I can't remember, but yeah, it's sort of like Space Invaders but in 3D. But with just a scene got alien. All right, so this takes as input what you see, and the output of this model is what to do. And so this is our machine learning model that's going to learn to play Doom. Hopefully, I mean, I've never tried this. Let's see what happens. Right, then here we've got the sort of main loop inside this name it called main section. Basically, it's going to iterate over episodes. So each episode is a game. The bot starts the game. There's a monster there, has to shoot the monster. It has like 200 frames to shoot it. If it doesn't shoot it, it like loses points, and you go to the next game. I think it just loses like 1 point. It gets a negative reward of -1 for each time step. If it actually manages to shoot the monster, it gets a positive reward of like +100, and that's the end of the episode. And so we're just going to do a bunch of episodes, like 10 or 20. And for each episode, we're basically going to iterate. So each iteration of this loop, we're going to get the current screen buffer, like what you can see. We're going to convert that into a torch tensor, throw that through the model, use a softmax to convert into probabilities. And then currently we're using an argmax to convert that into the probabilities into action. We just take the most probable action, that's the action we're going to do, and then we give that to the game using the game.makeAction, passing in our chosen action that's selected from the actions, available actions, using the action that came from our network. Then we get the reward, and at the moment we just throw away the reward. Right. So the next step, well, there's a couple of next steps. The first step is instead of argmaxing, we need to sample. So basically, we're going to do the most probable thing usually, but not always. Sometimes we will do a less probable thing. Occasionally, we will do a really unlikely thing. So that's the first thing we're going to do. And then the second thing is we're actually going to get it to start learning. So we're going to use the reinforcement algorithm. Luckily for us, when we search for how to sample, from this probability distribution, this one, in the torch doc, we're going to use something called a categorical distribution. And then when we look in the doc for that, happily for us, it's going to tell us how to do the whole reinforce bit. So reinforce is the algorithm in order to get the model to learn. It's one of the simplest algorithms, so it's fairly powerful. All right. So so let's figure out how to do the sampling. So we're going to go to the pytorch.org doc. So pytorch.org/docs. And then we're going to find the distributions. So distributions. So I accidentally went to distributed style, but it's distributions. And if we go to distributions, luckily for us, it tells us exactly what to do. It's talking about like reinforcement learning. Reinforce, this is the algorithm we're using. So reinforce does not equal reinforcement learning. Reinforce is an algorithm to do reinforcement learning. It's also called policy gradients. It's not the only way. You'll also hear of like Q-learning and various other things like that. So we're going to use policy gradients. So there's a whole bunch of maths, but basically we don't have to do the maths because we just do this. It does it all for us. So let's first start by sampling our action from the probability distribution rather than argmaxing. So policy network is the model. Probs is the probability distribution. We're going to create a categorical distribution from the probabilities, and then we're going to sample for that. So let's do that. All right, so it's torch.distributions, right? So from torch, import distributions. All right. Oh, I guess we should run this again first, just to check it runs right. So Python, ViZDoom, part 4. So this is like part 4 before we modify it. And then the version I'm going to save out to GitHub is the modified version. All right. So there we go. So it runs and does random stuff, sort of, and gets negative 200 reward because it's never actually shooting the monster. But if you run enough episodes, eventually it will shoot a monster and get some positive reward. All right. Okay, so yeah, so let's import the distributions. And all right, so we're going to stop doing the argmax. And so we've got the probability distributions. I've got so much dead code here. Should we delete some of this dead code? I'll delete some of it anyway. All right, I guess we can, well, we can leave that. All right. So, I guess we can delete that. All right. So basically, first we're going to create this thing called M, which is a distributions dot categorical, and we pass in the probabilities. I did buy a license for Sublime a while ago. I haven't bought one recently. All right. So we simply do categorical on the probabilities, and then we do m.sample gives us the action. So action equal m.sample, and so we can print the action, which hopefully is an integer. I guess we can print the type of action, and we can also print the probabilities, and we'll just run that like that. We have to learn to spell categorical, so there's a C here. All right, so here's the action probabilities. The most probable is this one, so it'll be index 1. But because it's sampling, it actually shows index 0. and it's a torch.tensor. So we want to turn this into a number that we're going to pass as an index into the actions list. Then we need to call dot item. All right, so let's run it again. We're going to get a different probability distribution. Here the maximum is index 0, but it's chosen index 2, and now it's an int. Okay, so actually we can simply pass that as input here. So yeah, right. So let's run that. So before, remember that it was sort of always doing the same thing, but now that it's sampling, sometimes it moves left, sometimes it moves right, sometimes it fires. So it's exploring the environment a bit more. It's not learning yet, but it's at least like exploring. So there we go. All right, so let's, I guess we can leave that in. Right, so we have now got it sampling, so good. Right, the next thing is we need to make it learn. Right, so how to make it learn? So I guess there's a couple of possible ways to do this. One is reward per step. I'm not sure if that would work. I think it might work, but it would be really, really slow to learn. I don't even know if it would work. And then the other word would be reward per episode. So, well, anyway, so let's first think about it. So it's making a bunch of moves. Like let's say it starts off and the alien is here. This is the alien, and then so this is like the scenario viewed from above, right? Alien is over here. Player P is here. And basically, what needs to happen is the player needs to move left, 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 and then fire, right? So ideally, it should do left, 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 and then fire. Okay, I guess I can write that out. All right, so this should be the moves it makes. Time step 1, it should do left. Time step 0, it should do left. Time step 1, it should go left. Time step 2, it should go left. Time step 3, it should go fire. That's like the ideal moves. Now let's think about what rewards it's going to get at each step. Well, actually, let's print the rewards, right? So we're going to print the rewards, and let's get rid of this so that it's less spammy. All right, so let's run that and see how that looks. All right, so basically each step is getting a reward of -1. I'm not sure what the -6 is. I guess the aliens shot us or something. And sometimes we should get a positive reward. I assume that if we actually succeed in shooting the alien, we're going to get a positive reward. All right, so there it shot the alien, right? We saw the alien die. And see, look, here we get a reward of 100. All right, so we get -1 when we don't, like nothing happens, we just pass time, and we get 100, or the model gets 100 when it shoots the alien. Right, so going back to here, the reward is, so here we get -1, -1, -1, 100. All right, now we're going to use this reward to train our network. So we're gonna tell the network, look, hey, you got a -1. You should do what you just did less. Hey, you got a -1. You should do what you just did less. Oh, you got 100, so you should do that a lot more. Well, let's think about what would happen if we trade it per step. So the player makes a single move, goes left, and we say, oh, -1, don't do that anymore. What is it going to do? It's going to start shooting or going right, right? I mean, it's like teaching it to do the wrong thing, not to do the right thing, right? And then eventually, when it fires and kills the alien, it's going to get like 100. So then it's like, oh, okay, I should do that a lot. So after a bit, what's going to happen? All it's going to do is shoot, right? So that's not going to be really useful. So what we really need is, I feel, is to do. So this is like reward per step, right? What we really need, I feel, is to calculate the total reward for an entire episode, which here is 97, and then we're going to give that reward to each of the steps that was done during that episode. So we're only going to give the reward to the model at the end of the episode. So if it manages to shoot the episode, everything that it did for that entire episode, we're going to give it a nice positive reward. And if it gets to the end and, it didn't actually kill the alien, right? So it's just -1 every time. Like the original reward, right? The reward the game gives it. Then the actual we're going to give it is we're going to give it -4 for each step. So it's going to learn, all right, what I did this episode, that was bad. We're not going to do that anymore. Right, so we're gonna take the total reward for an entire episode, and that's what how we're gonna do the reward. Right, now it's been absolutely ages since I did this, so I think that we need to take this loss and add them all together. So that means we need to keep around. We need to keep this around, and then we can calculate that, and then we're going to multiply it by the reward later. M.log prob. Yeah, we can calculate the m.log prob as we go through, right? We don't have to keep the m around and then calculate the log prob at the end. I think we can calculate it straight away. So let's do that. All right, so going back to our code. So we're going to keep this for each episode. We're going to have, I don't know what we want to call this, like action log probs or something. And we make it a list. So here, so we need the action and we need m. So here we've got the action. So here we've got m.log prob action. I don't know if action should probably be a tensor. So let's do the action equal action.item after this. All right. And so this is like our log prob. And we can print that. And then we're going to add that to action log probs.append log prob. Oh, and we need to store the actions, right? So actions is a list. And I guess we should store the tensor version. All right, so we're storing, so basically we're taking this m.log. Oh wait, no, we don't need that because we're already running the action, right? So we don't need the actions. Yeah. So we're just storing these action log probs. So we're storing this. All right, and then at the end of the episode, we can calculate the losses because we know the reward from the episode, and then we can do our backward. So let's try that. So we got the log prob, action log probs. Yeah, cool. Yeah, so let's see how the log prob looks. Log prob. All right, so log prob is a tensor. Yeah, it's got a grad event, so you can backprop, etc. Yeah, so I mean the thing is with reinforcement learning, you can't actually backpropagate through the categorical. But if we keep these m.log prob actions, then we can use the reinforce, which doesn't require backpropagating through this. It's sort of a way of doing backprop in the context of discrete sampling. Like you can't backprop through a discrete sampling. All right, so let's comment that out. All right, so we are calculating the m.log prob action and storing that into action log probs. I guess we may as well just, well, I guess it's fine like that. All right, so then at the end of the episode, we get a reward, and here is the reward. So let's, is this. And I want to normalize it because this is going to be like between like -1 and 100. I kind of think it would be good to normalize it to be like between like at least no greater than 100. So let's divide it by 100. Let's do it like this because sometimes it doesn't like doing like in place things. Like because with .torch and gradient, sometimes that doesn't work well. So I'm just going to explicitly do it like this. All right, so we got our episode reward. And actually the reward for the episode is going to be, it can be greater than 1 actually. But generally it won't be. It'll be between like, so if I didn't divide it by 100, I think it's going to be between like -200 and 100 or something like that. Like if we kill the alien straight away, we get +100. If we never kill the alien, I think we get like a -200 because there's 200 time steps. I think the number of time steps is set in one of these options up here. Like set episode timeout to 200. So the worst case, it's going to get like -1 for 200 steps. It's -200. So if we divide by 100, it's not perfectly normalizing it into like -1 or something like that, but it's not terrible. All right. So now we're going to calculate our loss. So let's calculate the losses per time step. So that is going to be, so we're just going to take each of these and we're going to multiply the reward, right? And I think this should be negative. I guess we could just store the negative. Should we store the negative? No, let's store the positive, and here we'll do the negative. So here we're going to do minus log prob times episode reward. And then take the sum. I'm not sure if we can just use a normal sum for this. I think we might have to like do a torch.stack and then a sum, something like that. So let's do losses t equal torch.stack maybe. Let's print out how that looks. And then abandon. All right, so we get a tensor and it has a grad fn, so this is going to work with backprop, etc. Yeah, and then we can just take the sum of that. So loss equal this dot sum, and then we can print the loss, and hopefully that looks okay. So all of this is taking forever, and also like let's turn off the window because that's so slow. All right, so here's our loss, and it's got a gradient. Yeah, let's turn off the display of this. Let's comment that out. All right, so here's our reward minus 255. Here's our loss minus 560, and then we can backprop through that. All right, so let's end this video here. So what have we done here? We have added in the sampling from the categorical distribution, and we have thought about how we're going to give the reward. Like, are we going to give it per step and per episode? And we decided, you know what? Let's give it per episode so that we reward, so that we reward all of the actions along the way, not just like the fire button. Otherwise, it's just a fire all the time. And then what we decided is that this we can calculate each time step and just store the result. And then at the end of the episode, we're going to take each of these, multiply by the reward, sum them all up, and that's the loss. And that's where we got to now. So we have the loss. So now we've got the loss, we can then backprop, but we'll do that in the next video. So see you there.